G'day folks, today's part looks pretty much like the drawing on the screen, the right hand end, and that happens on both ends. Here I'm using the parting tool as a material stop, and the spot drill goes deep enough to create a chamfer for the drilled hole. Here I'm using a deep hole jobber drill which has a faster helix than a normal jobber, as you'll see when we look at the video. I'll be using a 35-degree insert to do the turning profiling. Then we're cutting a 32 TPI Model Engineer thread at 2000 RPM. Doesn't take long. Then the 2mm wide parting tool cleans up that shoulder and parts it off. Then the parting tool goes back to the stop position and the subroutine starts again. Right, here we go. Let's make a part. There's the spot drill going deep enough to leave a chamfer for the drilled hole. There's that rapid helix you can see on the deep hole jobber drill. That's a 4mm drill. Here's a 35-degree turning tool. Doing the other end because it's got to be threaded anyway. It's the same as the right hand end. But I was going to do it a different way, but I ended up just doing it the same way as I did this. It was easier than messing around with the tooling. So it looks a bit strange, but you'll see in a little while what happened there. This is running at 2x speed. I was going to say it's so the bloke at the back doesn't fall asleep, but it's only 3 of you watch my videos, so it really doesn't matter too much. Nobody's going to go to sleep because you're all sitting in the front row. My right hand holds the material in place while my left hand closes the collet. This is the program for the next bit of machining. You don't see it all in the simulation because it's all just whizzing up the screen, so I thought I'd show it as a single piece. Now we're doing the other end. I enjoyed it so much I did the other end as well. Amazing. Nothing different to look at. Slowing down to 2000 RPM. 7 cuts I think it is. It's such a tiny thread.